I want to show you how to evaluate definite integrals by hand. So the first problem we have is I have a parabola that is negative x squared plus 4, and I want to find the area where x is between negative 2 and 2, and then I set up my definite integral. So this is a definite integral. X goes from negative 2 to 2, and then the integrand is negative x squared plus 4 dx. So that follows 4 steps. The first step is antiderivative. If you don't know what antiderivative is, it is okay. I will show you how to do it in this video. And then we plug in the b to the antiderivative, plug in a to the antiderivative, and then we subtract the result. That looks very complicated, but let me show you how to do it. So this one, the function is negative x squared plus 4. So let's go back to differential calculus really quick. What is the derivative of this function? The derivative is negative 2x. How do you know? You bring the 2 down. So negative 2x, and then the derivative of 4 is equals to 0. Again, you bring the 2 down, and then 2 minus 1 is 1. So the first terms become negative 2x to the first power, and then the derivative of 4, a constant, is equals to 0. That is correct, but we are doing antiderivative. So what is anti? Anti means you do the derivative backward. So let me show you the first step. So the first step is we are not going to bring the 2 down. We are going to take the 2 and then add 1 to it. So in derivative, you bring it down and then minus 1. In antiderivative, you take the 2 plus 1 and then you put this in the denominator. So you still have your negative 1. The negative sign is part of the function. You have the 2 plus 2 in the denominator. And then for the 4, the derivative is 0, but the antiderivative is 4x. And then such that, this line means such that x goes from negative 2 to 2. So let's clean up the 2 plus 2. So you have, the 2 plus 2, the 2 plus 1. Why do I do 2 plus 2? Yeah, take a look. You have a 2 plus 1, and then the denominator, you have the same thing. All right? And then the antiderivative of 4 is equals to 4x. So let's clean that up. You have negative 1 over 3 and then x to the third power plus 4x such that x goes from negative 2 to 2. I want you to check your answer really quick. How do I know this is the correct antiderivative? To answer this question, take the derivative of that. You will be able to get back to the function. Can you do that for me? Take the derivative of this. Bring the 3 down. 3 minus 1. Derivative of 4x is equals to 4. So we just go back to the function. All right. And then we are going to do the plug-in. So we are going to plug in the 2. Put the result right over here. And then plug in the negative 2. Put the result in the second parenthesis. Show all the work. Negative 1/3. So we have 2 to the third power plus 4 times 2, and then we have negative 1/3, and then negative 2 squared plus 4 times negative 2. And then for the antiderivative, we call this capital F of x, and then this is f of 2, and then minus f of negative 2. But you don't need to write that on your paper. So what do you get? You have parenthesis, negative a over 3, and then plus 8, and then minus, that must be a minus. This has to be a minus, hey, here. This has to be a minus. It must be a minus. Always a minus. And then we have, that is a negative a over 3, right? So that is that a third power? Because I wrote a 2. So that is a third power. So that brings up a negative. So we have a negative, we have a positive a over 3. And then minus 8. So what is that equal to? Don't break up the parentheses. So we have a negative 24 minus 8. That is a 16 over 3. And then minus negative 16 over 3. And then negative 16 plus negative 16. So that is a 32 over 3. What is this equals to? This is the area under the curve of negative x squared plus 4, where x goes from negative 2 to 2. So this area, so let me just write this down. So the area under this parabola is equals to 32 over 3 from -2 to +2. So from x equals to -2 to x equals to +2. The total area, like this piece, is equals to 32 over 3. Okay, so moving on to the next problem. So you should feel better as you solve more and more problem. So the next problem, I'm going to follow the color code. So this is an integral. They want to go from 2 to 5, right? So 2 to 5, we have x to the third minus 10x squared, and then plus 31x minus 30, and then a dx. So let's do the antiderivative. So antiderivative, we are going to add 1, so 3 plus 1, and then put this in the denominator. That is not a tough job to do, right? Minus x2 plus 1, and then put that in the denominator. After you get used to it, you can skip this line. And then x1 plus 1, and then we have 31 over that. 1 plus 1, I wrote 3. And then the antiderivative of 30 is 30x, because the derivative of that gives you the 30. And then we have 1 over 4, x to the fourth, minus 10 over 3, so 10 over 3, x to the third, and then plus 31 over 2, we have x squared, and then minus 30x. The antiderivative is done such that x goes from 2 to 5. X goes from 2 to 5. And then what else? Oh, check your works. So when you take the derivative of this, you can get back to the given function. You can do the work right now. I'm going to do that for you. Take the derivative of that goes back to the given function. And then we plug in the phi and then plug in the 2, right? Okay, plug in the phi. I'm going to use a square bracket. So we have 1 over 4, and then phi to the fourth power minus 10 over 3, phi to the third power plus 31 over 2, phi square, and then minus 30 times phi. So that is the plug in the phi. And then minus, always a big minus. Plug in the 2. We have 1 over 4, 2 to the fourth, minus 10 over 3, 2 to the third, and then plus 31 over 2, 2 square, and then minus 30 times 2. And then what do you have? You have a negative 9 over 4. So you have a negative 9 over 4. This is the area. And then how come the area is negative? So we already talked about that the area below the x-axis is negative. And then the area above the x-axis is positive. So what is the total area equals to? So the total area of those region is negative 9 over 4, because the negative piece is much bigger than the positive piece. So when you add them up, so this is a positive and then this is a negative. So this is negative, this is positive. When you add them up, so you have a positive, so let's say a 2, and then you plus a huge negative value, so let's say 2 plus negative 10, then you will end up a negative. So this one you can do, here is what you can do. You can try to do this. So if you do the integral just for your own, for your work, so from 2 to 3, so you will get the positive part, f of x dx. So that part gives you 5 over 12 if you did your math right. And then you can go again from 3 to 5, and then f of x dx. So that piece gives you a negative 8 over 3. And then when you add them up, so these two, the sum is equals to negative 9 over 4. All right, so let's move on to the square root function. So we have a square root of x where x goes from 0 to 4. Okay, let's do that. So we have a square root of x. So we have an integral from 0 to 4. We have a square root of x dx. Square root is 1/2 power, 0 to 4, x to the 1/2 power. And then how do you do this? You have x 1/2 plus 1, and then you put this piece in the denominator, and then such that x goes from 0 to 4. And then you have x 1/2 plus 1 is 3 over 2. You put that in the denominator, so the reciprocal is 2 over 3, and then such that x goes from 0 to 4. And then you can take the derivative of this to get back to the original function. plug in the 4, plug in the 0. So you have a 2 over 3. So you plug in the 4, you have a square root of 4 to the third power, always a minus, and then 2 over 3, and then you have a square root of 0 to the third power, that is just a 0. And then what is the final answer? The final answer, you have a 2/3, and then 2 to the third power is 8, and then you have a 16 over 3. And let's put the region right over there. So from 0 to 4, right? So from 0 to 4, and then this area is equals to 16 over 3. All right, and then what's next? The next one is the cube root function, right? So we have to go from -1 to 8. So let's change to red. So from -1 and then all the way to 8, we are looking for this area. So this is positive, this is negative. When you add them up, the area must be positive because the positive piece is so much bigger. Okay. So we have integral from -1 to 8. We have the cube root of x that is equals to integral from -1 to 8 x to the 1/3. And then antiderivative. So we have x to the 1/3 plus 1 and then 1 over the whole thing, such that x goes from -1 to 8. And then what is next? So we have x to the 4 over 3, right? So we have a 4 over 3 and then a 3 over 4. And then this is from what? This is from -1 to 8. So from -1 to 8. And then we plug in. So we have a 3 over 4. And then the third in the denominator. So that is a cube root of 8, right? And then after you finish, you raise the whole thing to the 4th power. Always a minus 3 over 4, and then you have a -1, the third power, and then you raise that to the 4th power. And then at the end of the day, so that is 2 raised to the 4 is 16, so 3 times 4, 16 minus 3 over 4, so this is just a 1. And then you have a 45, you have a 45 over 4. So the area of this piece and then this piece, the area is equals to 45 over 4. And then we have one more, the blue one. So the blue one, I want to go from 1 to 3. So from 1 to 3, so this is above the x-axis, so the area is going to be positive. And then this is a pretty special case because people make mistake all the time especially when they are learning antiderivative when they are new to the subject. So 1 to 3, we have 1 over x dx. So this one, if you use a power rule, you will be making a huge mistake. So let me do the right thing first, and then I will show you what the mistake is. The integral of 1 over x is just ln. This is just an ln x because the derivative of ln is 1 over x. Yes, that's it. You cannot use the power rule. So goes from 1 to 3, and then you have ln 3 minus ln 1. ln 1 is equals to 0. So the area is equals to ln 3. So this area is equals to ln 3. So what if you use a power rule? So this one, no power rule. You should write this down to remind yourself because I have seen this mistake on in my class. So we have, let's say you do power rule 1 to 3, you do x to the -1 dx, right? So what happened when you apply power rule? So you have x to the -1 plus 1, and then 1 divided by that, what do you have? You have 1 over 0, x to the 0, and then from 1 to 3, this is a mistake. So do not use power rule. And then, now, I want to do one more thing. What if, so the one more thing is, what if we switch the upper and lower limit? So what if we switch them? So let's grab an example. This is a pretty good example. I am going to grab this. So I'm going to do a copy and paste. So what happened when we switch, if we switch them? So what happened? Let's do a what if. So what if we switch them? Let's see. let's just erase this a. So what if I go from 0 to 4 square root of x dx? So the difference is you are going to switch this piece. So this piece will be switched, right? So that means you will be getting 2 over 3 and then square root of 0 to the third minus 2 over 3, 2 over 3, and then square root of 4 to the third power. So this one will be a 0 minus 16 over 3. Then you will be getting negative 16 over 3. So the answer is if you switch the upper and lower limit, the difference is the negative. So you will just go from a positive to a negative, from negative to a positive answer if you switch the top and bottom. Alright, so that is the end of this video. If you like the way I teach antiderivative and this definite integral stuff, give me a thumbs up and a subscribe, and I will see you all in the next lesson. Signing out.